Welcome to the Explainer. Today, we're going to unlock a literal superpower for your applications. Seriously, if you've ever wondered how modern apps talk to each other instantly, like how a payment system tells your database that a customer just bought something the very second it happens, well, the secret sauce is webhooks. In this Explainer, we're going to completely demystify webhooks, and we're not just going to talk about them, we're actually going to build a practical, step-by-step setup using Stripe and Node.js. So whether you're an absolute beginner or just kind of looking to solidify your understanding, stick with me. By the end of our time together, you'll have a fully functional webhook integration running right on your local machine. Let's get into it. So here is our roadmap for today. We're going to cover webhooks for absolute beginners, navigating webhook documentation, preparing the Node environment, generating the webhook URL, subscribing on Stripe, and finally, testing and important considerations. Okay, let's dive into this. Section 1, webhooks for absolute beginners. Before we write or clone a single line of code, we really need to understand exactly what we're dealing with. So by definition, webhooks are user-defined HTTP callbacks used to set up communication between two independent online applications. Okay, but let's translate that technical jargon, right? Think of a webhook like an automated text message or a real-time postal delivery. Instead of your app constantly calling out and asking a service, hey, did anything happen yet? How about now? What about now? Which, by the way, wastes a ton of resources, the service simply sends your app a message the exact moment an event occurs. You subscribe to an event, and when it happens, boom, you get notified instantly. Look at the core relationship we've got here. You have a source application, which in our tutorial is Stripe, and it sends an HTTP request filled with event data. Then you have the destination application, our local Node server, which is basically just waiting to receive that request at a specific endpoint URL. The source application sends these requests using standard HTTP methods like GET or POST. They're essentially just digital delivery trucks. It's a very simple sender and receiver relationship. Moving right along to Section 2, navigating webhook documentation. Look, I know reading technical docs can be super intimidating, so here are 5 essential tips to make extracting the right information completely painless. First, always head straight to the developer section of the provider's website. Second, use the search bar and literally type webhook events to jump right to the goldmine. Third, check the available event types. This tells you exactly what actions you can subscribe to, like say an item being added to a cart or a payment succeeding. Fourth, you gotta hunt down the security info. Are there API keys, IP whitelisting? You absolutely need to know how to verify the sender. And finally, note their policies on rate limits and retries. Like if a request fails, will they send it again? This little checklist right here, it'll save you hours of frustration. So the crucial point is getting our workspace ready. Section 3, preparing the Node environment. Okay, we need a place to actually receive these events. We're going to get our local environment ready in 3 really simple steps. First, if you haven't already, go create a free Stripe account using just your email. Next, we don't need to write a whole server from scratch. We're actually going to clone a demo Node.js API provided by HookDeck. You'll grab the Node.js webhook server example repository, which is basically just a folder of pre-written code, from GitHub. Once that's cloned to your machine, open your terminal, navigate into the root of that project folder, and simply run npm install to grab all the required dependencies. Seriously, take your time here. Getting this foundation right is totally key. Once everything is installed, it's time to flip the switch. In your terminal, run the command npm start. You'll see a message confirming your API is now booted up and actively listening for connections on port 1377. Think of this port as a specific digital door on your computer. Now, make a mental note of this right now. The endpoint path that's coded into the specific server to receive requests is /stripe-webhooks-endpoint. Our destination app is officially awake and waiting. Now for the tricky part, Section 4, generating the webhook URL. So we have a slight problem. Stripe is out there on the public internet, right? But our server is hidden safely away on our local machine. External services like Stripe require a publicly accessible, secure HTTPS URL to actually send webhooks to. They can't just send a package to localhost. To bridge your local server to the internet safely, we're going to use the HookDeck CLI. It's a handy command line interface tool. If you have the CLI installed, you simply open a new terminal window and run HookDeck listen 1337. This essentially tells HookDeck to create a secure tunnel directly to that digital door we just opened. Running that command triggers a really quick interactive setup right in your terminal. It's going to ask you a few questions, and here is exactly what you should type. For select a source, just choose Create New Source. When it asks what should your new source label be, type Stripe. The next one is super important. What path should the webhooks be forwarded to? Remember our mental note? Yep. Type /Stripe webhooks endpoint. Finally, for the connection label, you can type something like My Stripe API. Hit enter, and HookDeck will magically spit out a unique, public HTTPS URL for you. Go ahead and copy that URL immediately.
Okay, we are getting close. Section 5, subscribing on Stripe.
We have our source, we have our receiver, and now we have our secure bridge. Now it's time to connect the circuit and link Stripe to our local node API. Head over to your Stripe dashboard. Navigate to Developers, and then click on Webhooks. Up in the top right corner, click the button that says Plus Add Endpoint. A dialog box is going to pop up. Paste that HookDeck URL you just copied right into the endpoint URL field. Next, we need to tell Stripe what we actually want to listen to. Click the Events to Send dropdown and search for the account.updated event. This basically triggers anytime your account info changes. Finally, click Add Endpoint. Boom, you have officially subscribed.
Section 6, testing and important considerations.
Okay, this is absolutely the most rewarding part of the process, verifying our setup. It's the moment of truth. Let's see if our two applications are actually communicating. Back on that webhook screen inside Stripe, look to the top right and click the Send Test Webhook button. Just make sure the account.updated event is selected in the dialog and hit Send. Right now, Stripe is firing a simulated event payload across the internet through our HookDeck tunnel and straight to our local server. Let's confirm the success, shall we? Switch back to your terminal, the one running the HookDeck CLI. You should instantly see a webhook request printed right there on the screen. Success! HookDeck also kindly provides an event details URL right at the bottom of that log. Copy that URL, paste it into your web browser, and you can actually inspect the entire JSON payload that Stripe just sent over. This is exactly how you inspect the data so you know how to write the code to respond to it later on. But hold on. Before you run off and deploy this everywhere, you really need to plan for scale. When you start dealing with high-frequency events, traffic can spike suddenly, potentially overwhelming and crashing your server. You need to plan for scalability, often through things like asynchronous processing or message queues. You also absolutely must consider request failure, and of course, security, like verifying those API keys and webhook signatures that are embedded in the headers. And this brilliantly illustrates why understanding request failure is absolutely vital. As the source material points out, most webhook requests follow a fire and forget process. What does that mean? Well, it means the source application fires the data and just moves on. It often doesn't stick around to check if you successfully processed it. If your server crashes right as a payload arrives and you don't have persistent retries configured, that data is literally gone forever, which can absolutely wreck the integrity of your entire system. Always, always ensure failed requests are retried and that your data persists between those retries. You did it! You've successfully navigated the docs, set up a local node server, securely bridged it to the public internet, and caught a real-time event from Stripe. You've unlocked the core mechanics of modern app communication. So now that your applications can talk to each other instantly and reliably, what workflows will you automate next? The possibilities are honestly endless. Thanks for joining me on The Explainer, and happy coding!